Hello everyone and welcome to this presentation, which is all to do with binomial expansion. So what I'd like you to do please is to have a go on a piece of paper or on a whiteboard expanding these brackets for me. So your top one is a quadratic, then a cubic, then a quartic and so on, and you can always use the previous answer to help you work out what the next one will be. But I will leave you for a couple of minutes to have a go at that and press play again once you have done them all. Okay, so some answers then. So the quadratic, when expanded and simplified, would look like this, 3 terms. The cubic would look like this. The quartic would look like this. And finally, the power of 5 would look like this. And hopefully what you can see are some patterns developing based on our expansion. So we will be looking at what's happening with the powers of A, what's happening with the powers of B, and what's happening with these numbers at the beginning of each of those terms. How are they generated? And if we can work out what's happening with those 3 things, then we can use those skills to expand any expansion that I give you. So would you be able to expand A plus B to the power of 7 using the patterns that you can see above? Well, I would say that we can make a good start and we'll see how far we get before we run into any problems. So first of all, we know that there are going to be 8 terms altogether. And the reason why we know there are going to be 8 terms is because there's always one more term than the power that you have been given. So a power of 7, I know that there are going to be 8 terms. And I know that the first term of my expansion is going to be a to the power of 7. If you look at all of the other expansions, that follows that pattern nicely. And in the same way, I know that my final term is going to be b to the power of 7. And then what happens for all the subsequent terms is that the powers of a are starting at 7 and going down by 1 each time. And the powers of b are starting at 0 and going up by 1 each time. Now let me explain that a little bit more. If you look at that first term, there is actually a power of b there. It's b to the power of 0. But because b to the power of 0 is 1, we didn't need to include it in our answer, but it's there. And similarly, in the final term, which is b to the power of 7, we do have a power of a there, but it's a to the power of 0, which is also 1, and therefore we don't need to include it in our answer. So every single term that you're seeing there has a power of a and it has a power of b. And then we've only then got to look at what the numbers would be. We call them the coefficients. What would be the coefficients for each of the 8 terms that you've got in front of you? Well, I can see a little bit of a pattern in that when I had the power of 5, the second coefficient was 5, and with my power of 4, the second coefficient was 4. So with my power of 7, I know that the second coefficient is going to be 7. So I've written that in, and similarly, there seems to be a bit of symmetry. So there's also going to be a coefficient of 7 in that term near the end. So really, I'm nearly there. I've only got 1, 2, 3, 4 more coefficients to find, and then my expansion is done. And I haven't really needed to expand the brackets to be able to work these out. I've used my pattern spotting techniques to find these values. But what about these 4 missing coefficients? Well, I can use something called Pascal's triangle to find these other coefficients. So as you can see here, I've added an extra line at the top, which is just my a plus b to the power of 1 expansion. And what I can do now is I can write down the coefficients for each of the terms. So for our first line, our coefficients are 1 and 1. For our second line, our quadratic, our coefficients are 1, 2 and 1. Our third line, which is our cubic expansion, we've got coefficients of 1, 3, 3, 1. And I can carry on. So here is my next line, and here is my final line. Now, how are these numbers that you are seeing in Pascal's triangle, how are they being generated? Well, what's happening is that we are adding any two consecutive terms to make the number beneath them on the next row. Now, if you're not quite sure what that means, let me demonstrate. So here is an example. We've got the 4 and we've got the 6, and if we add them together, it will give us the 10 underneath. And if you look at other pairs within Pascal's triangle, you will notice that that pattern is exactly the same for all of the other numbers that you're seeing. And the only other difference of that is the fact that each of my lines of Pascal's triangle begins with a 1 and ends in a 1. So I can now start to fill in a few more lines of Pascal's triangle in order to find the coefficients that I need for my expansion. So the next line, 1, 6, 15, 20, 15, 6 and 1, that would be if I have a power of 6, and then the coefficients that I need will be on the next line, which is, as you can see here, 1, 7, 21, 35, 35, 21, 7 and 1. And they fit nicely into the gaps that I have for the expansion earlier, which I'm now filling in. So there we go. That is an example of how we can start to develop the skill of binomial expansion in order to expand these brackets rather than having to manually multiply all the brackets out one by one. Okay, so let's develop this idea a little bit further, and we're going to use our calculator to get the coefficients that I showed you on the previous slide using Pascal's triangle. So your calculator will do that work for you rather than having to write out Pascal's triangle until you get to the line that you need. So this is for your notebooks, please. If you can write notes in your notebooks on this slide, that would be great. So the button that we're going to be looking and using to gain these coefficients is the NCR button, and we can find it just here above the division. Please don't get it mixed up with the one next door to it, which is the NPR. We don't use that button on this course. So it's just the NCR button that we're going to be using to find these coefficients. And what this button does is it's working out the number of combinations for picking R elements out of a total of N elements, which sounds very confusing. So I'll give you an example in just a moment of what that means in relation to the work that we've just been doing. Now there's a few ways of writing this value. So some people like to write it as NCR, as you see in here. The next method that we can use is this sort of vector form that you're seeing. This is the one that I tend to use when I'm teaching it. So this is a NR, I would call it R from N when I'm teaching my class. And the way that this value is worked out is by using this formula here. We call this exclamation mark in mathematics, we call it the factorial function. And an example of how we can work out the factorial of a number is explained here. So the explanation symbol is used in maths to denote the product of consecutive natural numbers that decrease down to 1. So for example, if I was wanting to work out the value of 5 factorial, then I would calculate 5 times 4 times 3 times 2 times 1. So we call this the factorial function. So 5 with an exclamation mark next to it would be read as 5 factorial. So this is an example. So to put it into some sort of context, so this would be 3 from 10, and it would be equal to 120. So you can try this out on your calculator. You'd type in the number 10 first, then you would type the NCR button by using the shift or second function option, and then you press the number 3, and that will give you your coefficient of 120. Now, if you're worried at this point in time about what numbers would need to go at the top and what number would need to go at the bottom, don't worry too much about that for the time being. It will all be explained when we come to do an example later on. If I was using the formula to work out this value, then I would be working out 10 factorial on the numerator, and then I would be working out 3 factorial times 7 factorial on the denominator. So that's quite nice because that gives you an idea of what these numbers should be if you were working them out using number 1, your calculator, or if you were using the formula to work out this value by hand. Now, this idea of a factorial and combinations is used a lot in statistics and probability. We will use it 3 or 4 times throughout the course of the A-level for different topics. But an idea of when this would be used is, for example, if you've got 10 prize boxes in front of you and you're allowed to pick 3 of those 10 boxes, how many combinations are there for you to pick 3 out of the 10 boxes that are there? And it turns out that there are 120 different ways that you could pick 3 from those 10. Okay, so by the time you come to do an assessment or an exam, you'll probably know how to use the binomial formula really well. But just in case you do have a mental block and you forget, then I can tell you now that the formula that you can see here, which is the very general form for what we've just been doing, the formula is in the formula book. Now, just a couple of things to notice about that formula. Number one is that this formula only works when the power is a natural number. What I mean by that is it is a positive integer. So as long as n is 1, 2, 3, 4, etc., then we can use the formula. Okay. And the symbol for natural numbers is given there. It's a bit of a flamboyant looking n, but that is the symbol for natural numbers. And as the course progresses, you'll see different similar symbols for different types of numbers that we come across. The other thing I want to mention is this idea of binomial has nothing to do with the power. So when we're talking about a binomial expansion, we're not talking about a power of 2. We're talking about the fact that there are 2 terms within the bracket. So that's what makes it a binomial expansion. There are 2 terms within the bracket. It has nothing to do with the power. And the formula itself, well, you can see again that powers of A, the first term, are starting with a power of n and going down by 1 each time. The second term, B, is starting with a power of 0 and going up by 1 each time. And the coefficients we've already discussed earlier on about how we can find those coefficients using either a formula or the calculator. Okay, so it's about time we looked at an actual exam type question that involves some real numbers rather than the general form that we've been using so far. So this one's definitely for your notebooks, please, and we are going to be expanding 1 minus 2x to the power of 5. So before we move on to that expansion, let's just remind ourselves of what the general expansion for a power of 5 would look like. So using the formula in the formula book, it would look something like this. So my powers of A are starting at 5 and going down to 0. My powers of B are starting at 0 and going up to 5. And then I've got my Pascal's triangle coefficients of 1, 5, 10, 10, 5 and 1. And remember, they can all be found on the calculator using the NCR button. But I don't want a plus b to the power of 5. What I want is 1 minus 2x to the power of 5. So I'm going to replace a with 1, and I'm going to replace b with minus 2x. And if I do that consistently across all 6 terms, I will end up with a correct answer. Now, before I reveal the answer, what I want to stress is the importance of using brackets, particularly when, I'm going to be squaring the minus 2x, I'm going to be cubing the minus 2x. If I'm not careful, I'm going to get my negatives and positives mixed up, and potentially I'm going to get the wrong answer. So the line that I'm about to show you is one that we would suggest all students do for any binomial expansion question. So I'm showing it you now. I've got my coefficients of 1, 5, 10, 10, 5 and 1. They don't need to go in a bracket. My powers of 1 are starting at 5 and going down to 0. So even the 1 is in a bracket, as you can see. And my powers of minus 2x are starting at 0 and going up to 5. And again, you can see that those minus 2x's are in the bracket, so that it just makes that idea of raising them to a power that much easier. So that's the correct answer, but it's in a very raw form. So our final job would be to tidy this up, and that would give us our final answer of, and you can see it there, 1 minus 10x plus 40x squared minus 80x cubed plus 80x to the 4 minus 32x to the 5. And what I really would recommend you doing is just spending a couple of minutes now making sure you understand exactly why each of those terms are either positive or negative and where each of those coefficients come from, because that is where 90% of the mistakes are made when doing binomial questions. It's not that we can't use the formula, we're all very good at using the formula, but the numerical errors are often what let us down. So have a look at this very carefully and just make sure you understand exactly where each of those terms are coming from. So it's your turn now. So you don't need to do these in your notebooks. You can do them on paper or you can do them on a whiteboard. And there are 3 expansions to have a go at. They're all very similar, but in their own way very different. I would like you then, if you get time, to also have a go at numbers 4 and 5, but I will be going through those in a little bit more detail towards the end of the presentation. So I'd like to spend about 10 minutes on this. Come back to me when you've had a go at least the first 3, because I'm going to give just the answers to the first 3, and then I'll go through numbers 4 and 5 in a little bit more detail. So about 10 minutes, and then come back to me when you've had a go, please. Okay, good. So number 1, if you've expanded that correctly, you should have 5 terms, and they should look like this. Number 2, the part of number 2 that will catch more people out than any is the minus x. So be careful when you're using the powers with the minus x. Also, there are going to be 7 terms to this expansion, so it can get a little bit messy, and we do see a lot of mistakes made on that one. And number 3 is a nice one because of course the 1 over x. So don't forget, when you square a fraction, for example, you're going to square the top and square the bottom. When you cube a fraction, you're going to cube the top and cube the bottom, etc. So be careful with number 3, but it is quite a nice one to do, and if you've done that correctly, you should end up with these 6 terms. You don't have to write them using fractional notation. You could use negative powers of x, but I just think it looks nicer when you're writing your answer in this form. And then number 4 and number 5, I am going to go through these in a bit more detail in a moment, but if you have had a chance to have a look at the answer, then you should end up with 241,920 for the coefficient of x cubed. Don't worry if you're not sure how to get that number. And for number 5, you end up with 132. So the final 2 slides of this presentation are looking at questions like 4 and 5, where we are either finding the coefficient of just a single term, or we are multiplying 2 expansions together. So we'll finish by looking at questions 4 and 5 together and making sure that we're happy as to where those answers have come from. Good. So this is question number 4 from the previous slide, and this is definitely for your notebooks, because this question, or this type of question, is asked a lot. Because the examiner can ask this question, and it means that you don't have to spend an absolute age doing the full expansion, because your job is to find just a single term. And in this case, it's the coefficient of x cubed that we need. So how can we do it without actually finding all 8 terms of the expansion? Well, it comes down again to that pattern spotting method that we were using earlier. So in our formula book, this will be what the x cubed term would look like. We've got a power of 7 altogether, so we will be looking at 3 from 7 for the x cubed term. We know it's going to be b cubed because that will be our 3x cubed, and that's what will create the x cubed term, which means that we also have a to the power of 4. So that will be in essence our 4 to the power of 4 if we replace a with 4 and b with 3x, which is what we're going to be doing to answer this question. So I've worked out my 3 from 7, which gives me a coefficient of 35. So that's complete. And now if I compare that with my 4 plus 3x to the power of 7 expansion that I was given at the start, I now know that I'm going to replace A with 4 and I'm going to replace B with 3x. And if I do that, then this is the term that I will end up with. And now it's just a case of working through the maths, making sure that I work out the correct values for the powers, and that's going to give me my coefficient. So 35, 4 to the power of 4 ends up being 256, and remember 3x all cubed gives me 27x cubed. And if I multiply those three numbers together, I do get this 241,920x cubed, which for some will be what they write down as their final answer. But we've got to be a little bit careful because the question says find the coefficient. It didn't say find the term. So I'm just going to make sure that I get all of my marks by just writing down the coefficient, which is the number before the x cubed. So going back to this slide, we've now answered number 4 together. We'll also now have a look at number 5 to complete the set. So this one will be for your notebooks as well, please. So here it is, here's number 5. And again, if you were able to do this question previously in the time that I gave you, then great. But I'm going to explain it to everybody now, and please can we have this in our notebooks, because again it's a very common type of question. So we again are interested in finding a single term, and the single term that we're finding is the x to the power of 7 term. But what I'm seeing here is something slightly different, which is where I've got two expansions being multiplied together. So the way that I'm going to do it is I'm going to expand each of these two separate expansions, and then I'm going to multiply them two together. So it works out, and you can do this in your own time, but it's using the skills from all of what we've learned so far. It turns out that 3 plus x to the power of 5 ends up looking like this, and 1 plus 2x cubed ends up looking like this. And again, you can check that for yourself in your own time. Make sure you do get the same answer as me. And what we're then going to be doing is we're going to be multiplying these two expansions together. So I've wrote them side by side, as you can see here, but I'm not going to expand every single term. What I'm going to do is I'm going to look to see how many will create a power of 7, because they're the only ones that I'm interested in. So if I'm looking along here and I'm thinking about what will happen when I multiply these two brackets together, how am I going to get terms that involve x to the power of 7? Well, in actual fact, there's only two ways that that can possibly happen. So it's going to happen when I multiply the x to the power of 4s in the first bracket by the x cubes in the second bracket. And the second way that I'm going to end up with x to the power of 7s is if I multiply the x5 term in the first bracket with the x squared term in the second bracket. And you can see that I've done that with both of these underneath. And if I work out my two multiplications, it gives me 120 x to the 7 for the first one, 12x to the 7 for the second one, and then if I add them together, which is what I would normally do once I've expanded everything within my two brackets, I end up with 132 x to the power of 7. And again, because the question only asks for the coefficient, then my final answer is just going to be 132. So a nice little question this. It involves you having to expand those brackets using the skills that we've seen so far, and then not necessarily having to multiply out those two brackets in full, just picking out the ones that we need to create the answer that we want. Now it's time to practice all those skills. So on page 62, exercise 1.3, all of the different types of question that we've seen today will be within that exercise. Any problems, speak to your classroom teacher, please, and I will see you on the next presentation. So thank you for listening, and yeah, have a go at that exercise. Any problems, like I say, make sure that you ask for that help.